Hi, and thank you for joining me today to talk about searching your app's data in UWP. I'm Adam Wilson. I'm a program manager on the Windows searching platform, the team that provides the local searching power behind Cortana, File Explorer, OneNote, and many more apps on your system. Today I'm here to talk to you about how you can help your users find their content in your app more quickly. Thanks to years of having search engines, users are now used to being able to find their data quickly and easily anywhere they go. Unfortunately, as a developer, you want to be able to focus on the core experiences in your app, helping their users manipulate their content, not just find it. In UWP, we've added some great features to help you as a developer get users to find their data quickly and move forward with that data as soon as possible. Today we're going to walk through how as an app and why as an app you would want to use system searching with your data and the different ways you can do it. There's two main ways that we're going to cover today. The one is the indexed folder. Now this is a very simple method to use, and I'm going to try and keep it so simple that I would expect that somebody can add this to their app today after watching this video. And the reason I can say that is because I've done it before. It is doable, it's great, and it adds a great experience into your app. The other thing we're going to cover is the basics of the content indexer. Now this is a more flexible way to add searching into your app. Unfortunately, it's a bit more complex. So we're just going to cover the basics today, and you can do a deep dive and cover some more data later. But the first thing is, why use system search for searching in your app? Well, users expect to find their data quickly, and you as a user can know this. For example, looking for settings on your PC, people expect to be able to search for them within the Settings app. Why not have the same experience within the settings in your app? But there's a lot of data that you don't want to share with the system. You don't want to share with other apps. In that case, you need to keep it private and out of the way of other apps that may be trying to suck it up or do something that your users wouldn't appreciate. And the last reason to use system search, and this is the big one for me, is it's just so easy to use. It's built in, it has a powerful query language system search called Advanced Query Syntax. Now this allows you to combine natural language queries from your user with apps-shaped queries that has the power of SQL behind it. So it's a great language to use to combine both what users are able to do and what you're able to do in your app. And the biggest thing, and the reason why I always use system search, is internationalization. There are so many languages in the world, so many locales, so many different ways of saying the same thing. And as a developer, I want to be able to support as many customers as possible with all my app experiences. But I may not know that much about the Thai language. For example, I have a hard time understanding and reading diacritics in that language, which means if I tried to write my own search experience in it, it wouldn't be great. Fortunately, by using system search, I can let somebody else deal with that and just leverage it in my app, and I get to look like the genius. I get to look like the person who understands the language and creates the great experience for those users. So let's talk about the two methods. The first is the indexed folder. In the indexed folder, the app is going to create a special folder called indexed to put the data in that it would like to make searchable. It's very simple to use. Any app can use it, and it works with any file type that you can write into that folder. It also works great with static data, and you can see the example on my slide, which is the Settings app. This is how search in the Settings app works today in Windows. When you type a search query into the search box in the Settings app queries the indexed folder and returns results out of that folder into the view. And that's just an example of how we have leveraged this in Windows to have a great international searching experience, and how you can do the same in your app to have the same great experience that you see in the Windows apps. Now, some data doesn't fit great into a file format. The marquee example of this is OneNote files. When OneNote creates a file and they want it to be searchable, it doesn't fit nicely into a single file. They have their own very complex data structures. So in that case, they can't use the indexed folder. They use what's called the content indexer. The content indexer works on a push model, where the app packages up the data into a property bag and then passes it to the system. The system then takes that property bag and makes the data within it searchable. This gives you so much flexibility over the schema you want to use. The only restriction being that it has to fit within this bag, this property bag, which is, again, a free-form bag. You can put what you want in it. Now, it works great with transient data. The example, again, if you want to see on your system right now, is the edge address bar. As you type in a URL in the edge address bar, it queries through your history, which has been pushed into the content indexer, and returns results out. So this auto-suggest control that you see at the bottom of the screen, or you see in your Edge browser, is built directly out of the content indexer. And that's what we're going to work through later, is how you can actually build this auto-suggest control into your app. But first, let's dive into the indexed folder. And the reason I want to dive into that first is because it's so easy to do. And I'm going to prove it here. There's 2 lines of code on my screen, and that is what it takes to use the indexed folder. The first line, you're going to create a folder called indexed within your app's local storage. You create the folder, and then the next thing you're going to do is create a file within that folder. For example, I'm creating a file called indexedfile.txt, and then that's it. There's no more steps. The system will find that text file, index all the data that you put in that text file, and make it searchable for you to use. It's just so simple to use. Now, in some cases, your data may not fit cleanly within one of the file types that's known by the system. In this case, and as was the case with the settings app, you may want to define your own type of data to put in the indexed folder. Well, we have this facility called an app-content-ms file. App-content-ms files are a metadata-only file type that was created especially for the settings app to work great with the indexed folder. What it does is it allows you to be flexible in your schema. It'll not quite as flexible as the content indexer, mind you, but a little bit more flexibility than an MP3 or WMA file will provide for you. And it allows you to write out this file with some metadata, search it using the indexer, and return great results back to your users quickly. Again, and I want to reiterate this, all the internationalization, all the AQS querying, it all comes for free. There's no extra work required by you as a developer. There's no work required by your user. It's all built into the system. It's all ready to go. So let's do that. Let's step into a demo here of how we can use the indexed folder to add a great settings search experience in my app. So I have my application here. And in my app, I would like to show all the settings and then narrow the search down as the user types in my search box at the top. In a true app, I would want to set up these settings files during my first run experience. But to make it a little easier to explain today, I've actually put my first run experience behind this button here on my screen. So I'm going to click the button, and let's initialize the app, initialize these settings files, and see what happens. Okay, so the first thing you're going to do is you're going to see me here set up the indexed folder. Now, you remember that line of code from my slide? You'll see it appear right here again. The next thing I'm going to do is I'm going to take all the settings files out of my apps package and put them into the indexed folder to make them searchable. Now, because I'm a searching PM and I love searching, I do it using a query options and a little bit of AQS. If you want to just copy a folder, that's fine as well, but I wanted to throw a little flair in it for the demo today. And finally, the last step is I just copy these files into my indexed folder. And that's it. You're ready to go. While I've been talking, the files have been copied, the system's made them searchable, and we're ready to query it. So let's do that. Now, you can see here I'm creating my query over these files that I've made searchable. Again, the first thing I do is open up that indexed folder. The next thing I'm going to do is create a query for all my app content or settings files that I've created within this folder. Now, one thing to note here, and I've done this as sort of a special thing to make sure everyone's aware of, a best practices sort of tip, I've set the language here to ENUS. The reason I've done this is because my machine right now is actually not set up as ENUS. My machine is set up as Canadian English. But for the purposes of the demo, I want to be able to search in ENUS as well. If I omit this line, the query would actually assume that the input text is in Canadian English, or whatever the system's locale and language settings dictate. It's up to you as the developer if you'd like to force the user to use one particular language, or if you'd rather let them query in their native language or the language their machine is set up in. So there we go. The last step is create the file query, just as if you're querying any other location on the file system. Clear my breakpoint to be safe, and away we go. And here you have it. All my settings from my app visible on the screen. Now, let's say I want to search for the word color, because I don't like this white background. So I'm going to type in a search here. Oops. And there you have it. I found the color setting in my app. It's displayed right at the top, and as a user, I can go click, dive in quickly, do what I want to do, and get back to having a great time. Now, sometimes, because I grew up in the former British Empire, I spell color differently. Let's see what happens here. You'll note, because my machine is set up as EN Canadian, and I spelt color in the Canadian style, or the British style, the color results also appear at the top of the screen. And this is great. This works for any language, any locale. You just need to include the right strings, and we make search work for your users. If we actually dive into the color settings file, you can see I have two settings here. I have the keyword display color for English, or English Great Britain style, which English Canadian derives from. So again, you can set up these great searching experience very easily and have it internationalized for you just that easily. Again, the schema is available online. I'm not going to walk through all of the details here for you today, but it's very simple, very flexible, very easy to use. Now, what if you don't want to put your data in a file, or you have some data like OneNote that doesn't fit nicely into files? Well, this is where the content indexer comes in and is great for you. The content indexer is just so powerful. It's used by a bunch of different system apps on the system, and it's also able to be very flexible, to spread out, to have a schema that you define, that your app knows about, and without it being interfered by anything else. Unfortunately, that's a lot to cover today, and we want to be able to get a search experience into your app right now. So what we're going to cover are just the basics, how you use the content indexer to create a great auto-suggest control based off your user's search history. So let's talk about the basic model behind the content indexer first. The first thing you want to do is create this connection between your app and the system index. This lets the system know there's data going to be coming. Let's create a private partitioned off section for this app's data and prepare ourselves to start indexing data into that partition. The next thing you're going to do is create an item to be pushed into the index. This item is a property bag with a few other pieces of metadata about the item. You're going to build up this property bag in your app and push it into the index. The index will then take the data in the property bag, make it searchable, and call back to your app to say that the operation is complete. You're going to want to make sure that the index actually reports success. There are cases in rare situations where the index will not successfully index a property bag. If there's a corruption in the data or something else has happened in the app or on the system. Just make a quick eye out for these. Make sure the revision number actually jumps. And we'll show you what I mean by the revision number shortly. Now, to get the data out of the indexer, it's just like querying the file system. You're going to create a query in your app. You're going to set the list of all the properties that you want to search and all the properties that you want to be retrieved from the system index. You pass that query into the system index. It'll run the query using AQS, using all that internationalization logic we talked about earlier, and then return the results back to your app. The app is then responsible for parsing that property bag back into its object model. And a word for the wise, re-implementing iIndexable content helps a lot here. We provide an implementation of iIndexable content called indexable content, but using that data in your app is a little challenging. It's great if you can just re-implement this in your own class and then fit it right back into your object model, ready to go, ready to be used. So that was quite a bit. Let's walk through a demo here of how you would do that in an app. So in my app, I want to be able to search for my song history, to search for the most recently played songs on my machine and be able to play them again. Again, this data is going to be built up as your user uses their app, as your user interacts with your app, but for simplicity today, as opposed to watching me listen to a bunch of songs, I've hidden it behind a button, which simulates my user listening to a bunch of songs and creating that data. So let's just initialize up the indexer here and take a look at how this works. So to push data into the index, the first thing I'm going to do is take a look at the revision number. Now this is something that I've cached, and we're going to come back to this in a second, but just take note, I'm looking at a revision number from the registry. The next thing I'm going to do is I'm going to create this item. Now this item has been passed to me by another method, and you'll note it's content indexer extensions, and this is something that I've subclassed off of iIndexable content. And you can see I've added a bunch of nice friendly fields that made it very easy for me to fill it up and use it in this case. Now I take this item and I simply add it to my content indexer. Now what I'm going to do is after I add it to the content indexer is I'm going to check the revision number from the indexer. I want to be able to save this revision number so that the next time I use it, I can check it back up here. Now this code's called in a loop, so every time I push an item in, I save the revision number. After I've saved the revision number, I'm going to check before pushing the next item in. And the reason you want to check before pushing the next item in is to make sure the revision number hasn't reset or it hasn't jumped on you. If either of these have happened, it means either something on another thread is pushing information into the index, and as a developer, maybe that's okay. But in this case, I don't want another thread pushing information into my index, so I'm going to actually fail out if I recognize that. The other option is if the index revision number gets set to 0. This is a rare situation, but it can happen where the user actually goes and does something so catastrophic to their disk, the entire system index gets reset. In this case, all the data that's been previously pushed in will be lost, and it will be up to the app to re-push it. Again, the revision number will count up from 0 as the more data is pushed in, and we expect this to be rare, but your app should be able to handle it. So let's clear the breakpoint and finish pushing the data in. Now, my users created some data. I'd like to go see that song that I saw being pushed in and play it again. And here we have it. So I'm going to create a query against that system index. So we're using the same index that we talked about previously. And here's my query string coming from the user. You can see I typed in the character L because I'm looking for the song A Light That Never Comes. Now, you'll note I'm using the query properties here. And let's just take a note that I'm using these properties, and we're going to come back to it in a little more detail in a minute. I then create a query using the query string and my query properties. Again, this has the full power of AQS. So if I wanted to be creative and use a bunch of more advanced options here, I could. But for our simple auto-suggest control, let's just stick with the basic user input. And then once I've created the query, I return it out and display the results in the auto-suggest control. So let's take a look what it looks like to the user. Oh, sorry, before we look at it to the user, remember I mentioned that you should subclass iIndexable content? Well, here you can actually see where I subclass iIndexable content. And this has actually allowed me to parse this data, this coming out of the content indexer into my object model in a nice little contained part of my code. You see here, I'm looking in this property bag that comes back out of the indexer. I'm looking, does it have a file extension? Which in this case, I would expect it to not have a file extension. Or does it have date modified? Again, these are things where, as a developer, it's nice to have these in my object model. You could spread this parsing code out throughout your code, but it's a lot nicer to contain it into one class which subclasses iIndexable content. It also, from personal experience, makes testing so much easier. If you can narrow down any errors with your data parsing or pushing data into the index to one class, that's just so much nicer to have, so much nicer to deal with. So we've parsed the data out of the content indexer into the object model, and we can see here's my auto-suggest control. And as I keep typing, it's going to narrow down the results. There we go. And there we have it. A great auto-suggest control built up using the content indexer. This is going to work in any language, no matter what songs I'm using, no matter what data I'm using. As your user types their search, it's going to give the auto-suggest options, it's going to be so fast, which is just great to have in your app. It's a nice experience for your users. They're going to love you for it. Now, I just talked a bit about these properties. You saw them at the top of the screen. I called them push properties. How did I know to use those? I think one of them was system.mimeType. There was a bunch of other properties in there. Well, all this information is actually documented on MSDN. The problem is, some of the MSDN documentation isn't that clear, and it's very dense. So what I'm going to do for you today is I'm going to actually pull up a page from the MSDN documentation, and we're going to walk through exactly how you read it to use it with the content indexer. Now, for fair warning, this is a bit complicated, but don't worry, we're going to narrow it down very shortly. You'll see on the left, I have pulled the documentation for system.music.albumartist, and on the right, the documentation for system.dateModified. You'll see these are both properties in Windows that you could look at right now for any MP3 or WMA file you have on your disk. But there's a lot of information here. What's the stuff that you need to know for the content indexer? Well, it's pretty simple. The first thing you need to look at is inverted index. Just do a quick check to make sure that's true. Most properties on the system it will be true for, but in the off chance it's set to false, that means the data won't be searchable. You can push in data for system.music.albumartist, but nothing's going to happen. The index will look at it and just drop it on the floor. So check to see is inverted index equals true. The next thing you'll want to check is column. Is column says, if I push this data into the system index, can I pull it back out again at a later time? If it's set to true, the answer is yes. And you'll see that I'm doing that for the content indexer there. I was pushing in the song title, and then I was pulling it back out. That's because the album artist, as well as system.music.title, are both set to is column equals true. The next one to look at is the max size. And this is the same as anyone who's ever used a C buffer before. Make sure that your data you're pushing into the buffer is shorter than the buffer. These sizes are all listed in bytes, so in this case I have 128 bytes, not 128 characters, which is careful if you're using C# because it will be encoded as UTF-16, which is 2 bytes per character. Now, as opposed to the actual encoding you use on this string, you could encode it as ASCII if you want. You could encode it as UTF-8. You could even encode it as UTF-32. But the system will take care of that for you. It will make it searchable in whatever language you push it in as. Just make sure that it's under the buffer size here. The next thing you want to look at is the data type. For date modified, it's a date time. For album artist, it's a string. There are other values that you might see, like uint32. Just make sure the data you're pushing in matches the data type. Again, if the data type mismatches with what the indexer is expecting, it will just drop the data on the floor because it doesn't know what to do with it. A word to the wise, the type date time in the property system documentation actually maps to datetime offset in C#, not the datetime class. The datetime offset also maps to file time if you're doing it in C++, so just as a heads up, it catches you a few times. The last thing to check is innate. Now this is where you'll see these two properties differ. System.music.albumartist is set isInnate equal to false. What does that mean? Well, it means to find out the value for that property, we're going to have to look into a file, or we're going to have to look into the property bag as the system to figure it out. For system.dateModified, the system thinks, no, I don't need to look inside of an MP3 file to find out the date modified. I can just ask the NTFS file system. It will tell me. Which is great. It means when you lay down files, you don't have to worry about updating the date modified. The problem is for the content indexer is if you try and push in a different value for date modified than what the index can calculate on its own, it will ignore your value and simply use what it calculated. So be sure if you're using one of these properties for the content indexer, isInnate must be set to false. And that's it. There are 100 different things you can look at on this screen, but you only need to know 5 to use the content indexer. So which one to use? There's just a couple options we've talked about. Which one is best for you? Here's a little handy chart to help you figure it out. But what you really need to know and what you really need to think about is your data static? If your data is static, it's a no-brainer. Go with the indexed folder. If your data is going to be changing frequently, you're probably going to want to lean towards the content indexer, except for in rare situations where you think, no, this data has a backing file already. For example, the user's cached MP3s on your system. Maybe because you're already caching those files on the disk, it makes sense to put them in the indexed folder. But if there's not already a file on the disk and the data is going to be changing quickly, I would highly recommend you take a good hard look at using the content indexer. As you see, you make a great auto-suggest control. You can also make that setting search experience out of the search results as well. It really just comes down to what your app needs, what your app wants. And that's it. We've covered 2 different ways that you can add search to your app very quickly using system search functionality. Both of these provide the same powerful query functionality, and both of them keep you the data private to your app. Once something is pushed into the content indexer or pushed into the indexed folder, no other app on the system can read that data. So the indexed folder, again, it's easier to use. It's quick to set up, it's quick to get running in your app, and it works great on static data. The content indexer is just so much more flexible. It works on transient data, but it's a little bit more complicated to use if you go the full distance with it. You can keep it simple by re-implementing iIndexable content and add to your app a great search experience. Thanks for joining me today, and I look forward to seeing great search experiences in all your apps going forward.